Hello, ladies and gentlemen. Welcome to the portal. I welcome you with this new video. Last time, on our last session, we did lesson one of acids and bases, where we have discussed the classification of acids and bases. We were classifying them as being strong or weak. We also looked at definitions of Arrhenius and Lowry-Bronsted. Okay, so if you haven't seen that video, please go back. I have explained a lot of things that were just highlighted in the examination guidelines. Okay, guys, so go and check that video. So now in this video, we'll focus on the following highlighted outcomes. So by the end of the video, you must be able to understand the outcomes highlighted by the bulletins. Okay, so the first one being reactions of acids and bases with water. So what do I want you to understand in this part of reactions? I want you to understand what happens when an acid reacts with water. What is the product? And when a base reacts with water, what is the product? Okay, so also I will talk about the monoprotic and the polyprotic acids. Okay, so in this bulletin we want to know how many protons, what is the maximum number of protons can an acid donate, or what is the maximum number of protons can a base accept. Okay, so also we look at neutralization reactions. So this neutralization reaction will be a reaction between an acid and a base. Okay, so later on titrations, we'll talk more of these neutralization reactions. Okay, so and then we'll also identify the conjugate acid base pairs in this lesson. And finally, we'll also check the hydrolysis of salt. So this hydrolysis of salt and the neutralization, I might mix it. Okay, and I might also mix reactions. I might also mix these two bulletins. Okay, guys, and this one it can come later on. Okay, so now let's start with the first one. Okay, so it's what the reaction equations of aqueous solution of acids and bases. Okay, okay, so this bulletin will focus on that. Okay, reaction equations of aqueous solution of acids and bases. Okay, so here meaning that we are reacting an acid, right, plus water. Okay, what do we get when we react acid plus water? We get hydronium ion plus what? The negative ion of the acid, the anion, which is the anion. Okay, so and then what happens when we react the base with water? So when we react base with water, what do we get? We get hydroxide we get a hydroxide ion. Okay, so plus what? We get the hydroxide and okay, a cation. Okay, what is a cation? A cation, it is a positive charge. Okay, plus a cation. Okay, so now I'll explain with a few examples here. So now, what is an anion? Anion is a what? It's a negative ion, guys. It's a negative ion. And then cation is a what? It's a positive ion. Okay. Another thing, in reactions, uh, we are going to look at balancing reactions. When we balance reactions, we must look at conservation of mass and also conservation of charge. So in acids and bases, we deal a lot with charge. Okay, so and I've noticed that many learners, they don't understand the issue of charge. Okay, so I will try to stretch that matter okay, in this regard. So now let's say uh, before we do anything, so guidelines of reactions. Okay, actually all reactions. Let me not saying acid and base on guidelines of reactions. Okay, so now what must happen? Number one, uh, mass must be balanced. Okay, mass must be balanced, and what? And charge must be balanced. Okay, so we'll get to that and you will see what I mean by that. Okay, so now for example, if I take let's say a strong acid HCl. Okay, so by now you know that HCl is a strong acid. Okay, so let's say I take a strong acid that is in solution plus water. Okay, and then what do I get? I will get the hydronium ion plus what? Plus the anion. What anion? The anion of what? Of chlorine, which is what? A chloride ion, Cl minus. Okay, so now you can see from here we get, when we add an acid to water, we get hydronium plus what? An anion, which is a negative ion. You see, so now what happened here and how are we balancing this thing? Okay, so if you can check now, if you can check number one, following guideline number one, if we check mass, let's start with a number of hydrogens from the left hand side. From the left hand side, how many hydrogens we have? We have one here, we have two here, so we have 3 hydrogens on the left. Okay, we have 3 hydrogens. Okay, let me write left hand side. Left hand side, we have how many hydrogens? We have 3 hydrogens. How many chlorines? 1 chlorine. 1 chlorine. How many oxygens do we have? We have 1 oxygen. Then what about on the right hand side? On the right hand side we have what? We have 3 hydrogens as well. We have one chlorine atom, and we have what? We have 1 oxygen atom. What about charge? In terms of charge, what do we have? So you'll notice that if a molecule does not show any positive or negative number, right? It means that its charge is zero. Okay, so it doesn't work like in maths whereby we say, for example, if it's X only, therefore we know that there's one at the top. No, it doesn't work like that. So in chemistry, a molecule, if it does not have any charge that is visible on top of it, it means its charge is zero. Okay, so on the left we have zero for HCl and what, and zero for water. So left hand side charge is what, is zero. Okay, and then what about the right hand side? So now on the right, check, we have positive 1. Okay, we have plus 1 from the hydronium ion. Okay, then we have negative 1 from the chlorine. So if you say 1 minus 1, how much do you get? You get 0. So now charge is balanced both on the left hand side and on the right hand side, and also mass is balanced on the left hand side and on the right hand side. So the equation is balanced. Okay, so one thing that I would like you to know is that always when an acid is donating a proton to water molecule, the water molecule will form what, a hydronium, and the charge of hydronium is positive 1. Okay, which is the plus only. So, and because the Cl is losing this H, the bond between the H and the Cl is going to go back to Cl, which will make Cl showing that it has gained an extra electron. Okay, so yeah, now let's do another example. Okay, so let's take nitric acid. Let's take nitric acid in water. So nitric acid in water, what is going to happen? We know that nitric acid, when it separates to form what? Hydrogen ions and what? And nitrate ions. Okay, so another thing that is important, you must know the charge of the anions. You must know what is the charge on a nitrate, you must know what is the charge on a carbonate, you must know what is the charge sorry, on a sulfate, you must know what is the charge on a phosphate. So now here we have what? We have water molecule. So remember I said that positive attracts negative. Okay, so how will this proton be attracted to this water? Well, this is simple. This proton will be attracted to this water because this water has lone pairs, and lone pairs are partially negative, are slightly negative. So the electron density is to this side of the oxygen. Okay, the electron density is to this side of the oxygen. So now we can say this water molecule on the side of the oxygen is what? Is slightly negative. Okay, so let me write it like this: the water molecule. Okay, so it's like this, and then here slightly positive, slightly positive. So now this proton, it will be attracted to what? To this lone pair, or to one of these lone pairs, because now this proton comes without any electrons. It will form what? It will form something like this. Okay, so this lone pair will be shared with this hydrogen, and when a lone pair is shared, we are going to have a positive charge here. Okay, when a lone pair is shared with this, because this one did not come with what? With an electron. Okay, so now what is this? This is a hydronium ion. Okay, so there is still one more remaining negative charge. Okay, so there's still one more lone pair, so not negative charge. So this is what? This is hydronium. This is how hydronium is formed. So now we are left with what? We are left with the nitrate, right? The nitrate is an anion, it's negatively charged. So when we add an acid to water, what do we get? We get hydronium. We get what? We get hydronium plus an anion. Okay, so hydronium is what? Is H3O plus, right? Plus what? Plus the anion. What is the anion? Is the nitrate. Okay, is the nitrate in solution. Okay, is the nitrate in solution. So now what about bases? If I take a base, for example, I take ammonia, right? I add ammonia to water. Okay, so when I add ammonia to water, what did I say? I said that when you add a base to water, you get hydroxide ion plus a cation ion. Okay, so now remember this is reactions. Okay, so check this. Okay, so now what are we going to get here? We are going to get ammonium ion, ammonium cation. Going to get, let's start with hydroxide. We are going to get OH minus hydroxide plus what? Plus a cation. What is the cation? Is the ammonium. Okay, is the ammonium. So you can check hydroxide plus what? Plus a cation. A cation is a positive charge. This is a cation. This is a hydroxide. Okay, guys. So how does this NH4 happens? How does it take place? So a nitrogen is something like this. Okay, remember from grade 11, a nitrogen is something like this. And then here we have a lone pair. Okay, so now and then here's our water molecule, right? Here's our water molecule. So our water is like this. Okay, so now you'll notice that this part of the water molecule is slightly negative and this part is what is slightly positive. Okay, so the electron density, it is what it is delocalized towards what? Towards the oxygen. Okay, so making these hydrogens positive. So now because these hydrogens are positive, they are prone to an attack by this lone pair. So this lone pair is going to take this hydrogen because you know it is not really satisfied with electron density, although it is satisfied with electrons, but the electron density, it is pulled away from it. So now this lone pair is going to take that hydrogen, and then this pair, this bond pair, this bond is going to go back to the oxygen. It will go back to the oxygen as what? Let me select a different color. So this bond pair is going to go back to the oxygen, right? When it go back to the oxygen, remember that here 2 electrons are shared. So oxygen has 1 electron and hydrogen has 1 electron. So when this bond pair goes back to oxygen, oxygen is going to have 1 extra electron. So this is what will happen now. Now because this ammonia is going to share its lone pair with the hydrogen that does not have electron, so it's going to be positively charged, the nitrogen. So what is going to happen is this: we will have this, so now here we will have this. So we will have a bond that we call a dative covalent bond. So because this nitrogen has shared its lone pair for bonding to the hydrogen that did not have any electrons, so it's going to show with a positive that I have shared my my lone pair with an oxygen that did not have electrons, so I am not happy. Okay, so now remember that this bond has went back to oxygen. Okay, so now here we are going to have what, H, right, with what, with oxygen that has an extra pair. Remember here it had 2 lone pairs. Now when this bond goes back, it becomes what, 3 lone pairs. So, and then it's going to show with a negative sign that I've gained an extra electron. So this is how hydroxide happens. This is how hydroxide happens, and this is how ammonium happens. Okay, guys. So this is what you have done in grade 11 when you were talking about Lewis structures and molecular geometry and electron pair geometry. So if you guys don't have basics with these things, it will be very helpful for you to revise things like ammonia. Okay, so and then you will be fine, because I noticed that you guys struggle with charges. Okay, so now let's go back to the okay, to the outcomes. Okay, now so as I was showing you that reaction of acids and bases in water, they form whatever that they form, that I've shown you. I've shown you a general equation for that. So now let me talk about monoprotic and diprotic acids in aqueous solutions. Okay, in aqueous solutions. Okay, so I'll talk about the reactions. First thing first, what is a monoprotic? Mono means 1, right? So mono means 1. So means 1 proton. Okay, mono, 1 proton. And then there's diprotic. So di means 2. Okay, so means what, 2 protons. Okay, what about polyprotic? Now polyprotic can be 2 or more, right? 2 or more protons. Okay, so a monoprotic acid, it is an acid that can donate 1 proton, and a diprotic acid, it is an acid that can donate 2 protons. A polyprotic acid, it is an acid that can donate 2 or more protons. Okay, so now let's check the solutions and compare. So if I can take HCl, is it a diprotic acid or a monoprotic acid? If you can check HCl, it has only one H, so it makes it a what? A monoprotic. So it's a what? Monoprotic acid. Okay. What about sulfuric acid? It can donate up to uh, uh, 2 protons if it has ionized completely. Okay, so it's what? It is a diprotic acid. What about phosphoric acid? We have phosphoric acid. So phosphoric acid can donate up to 3 protons. So it is what? It is a triprotic acid. So now, because for uh, 2 or more, we have an umbrella name for 2 or more protons. So we say they are what? Polyprotic. So both sulfuric acid and phosphoric acids, they are what? They are polyprotic acids. They are polyprotic acids. Okay, so now let's check their reactions with water. So monoprotic acid uh, in water. So now what I'm going to do here, I'm going to show also the stoichiometry that is taking place. Okay, so if I take HCl plus water, all right, what am I going to get? I'm going to get hydronium plus what? Plus the chloride ion. Okay, so now uh, you will notice this, that if I can check if the equation is balanced, so I have one hydrogen, okay, I have 3 hydrogens on the left, and 1 oxygen and 1 chlorine. Also here I have 3 hydrogens, 1 oxygen, 1 chlorine atom. So and then charge on the left is 0, even on the right is 0, because 1 minus 1 is 0. Okay, so now it is balanced. Okay, so now let's check this stoichiometry of monoprotic acids in aqueous solutions. Okay, so now you will notice that uh, we have 1 here, 1 here, 1 here, 1 here. So for every monoprotic acid, for every 1 mole, of HCl, right, that ionizes, uh, 1 mole of what? Of hydronium ion will be formed. Okay, okay guys, so in notation, how do they write this even in memorandums and in examinations? So they say 1 N for mole, right? 1 mole of what? Of HCl. Okay, the ratio is to what? 1 mole of what? Of hydronium ion. Okay, so also, because now we are talking about moles, also concentration works with stoichiometry. Okay, so meaning that for concentration of HCl, okay, for 1 mole of the concentration of HCl, uh, now in solution, when for every given concentration of HCl, that ionizes in water, there will be what? Uh, 1 mole of what? Of concentration of what? Of hydronium ion. Okay, so this is called the analytical concentration of HCl. It's called analytical concentration of HCl. Okay, this is just the concentration of hydronium. Okay, so now let's go to diprotic. Okay, so now a diprotic acid in solution, in aqueous solution. Okay, in aqueous solution. Okay, what are we going to have? So now, for example, let's take H2SO4 sulfuric acid. Okay, let's add it to what? To water. So what are we going to get? We know that we are going to get, because we are mixing acid with water, we are going to get what? Hydronium ion plus what? Plus plus the thing, plus an anion. Okay, so now you sulfuric acid, so when it has fully ionized in water, it forms what? It forms two two hydroniums and what? And a sulfate anion. Okay, and a sulfate anion. So now what I want you to see is that for every 1 mole of sulfuric acid that ionizes in water, 2 moles of hydronium ion will be formed. Okay, so what does this mean? It also means that for every for every 1 mole of analytical concentration of of sulfuric acid that is available or that is found somewhere in the course of the reaction, for every 1 mole of concentration of analytical concentration of sulfuric acid, 2 moles of concentration of what? Of hydronium ion will be present. Okay, why? Because this is a diprotic acid. So for every 1 mole that ionizes, 2 moles of hydronium will be formed. So this is very important. You must know it with your heart. You must understand it. Okay, so all right. So I wanted to explain something. Okay, so they can also show you that sulfuric acid has 2 stages of ionization. Okay, sulfuric acid and what stages of ionization. So first of all, we start with what? H2SO4, right? So in water, what do we have? Here we have we are going to have hydronium plus what? Plus hydrogen sulfate. Okay, so hydronium plus hydrogen sulfate. This is step 1. Step 1. Okay, and then now step 2 of ionization, what do we get? We get now the HSO4 minus, which is hydrogen sulfate, also in water, to get what? To get also another hydronium plus what? Plus sulfate ion. So if you can check here, uh, both step 1 and step 2, they are acid and base reactions. Okay, so here one proton was donated to the water molecule, and then hydronium was formed, and the anion was formed, which is the hydrogen sulfate. Also, second step, the hydrogen sulfate reacted with water and donated hydrogen to water, and then hydronium ion was formed, and what? The sulfate ion was formed. So how does it become what I showed, that the complete reaction of sulfuric acid gives us two molecules of hydronium ion. This is what happens. So if these are stages or parts of ionization, so we can have net ionization reaction. Net, it means that I'm going to add both reactions together. Okay, so if I can add the top and the below in the bottom, I will have H2SO4, right, plus water, okay, plus HS plus HSO4 minus plus the water again, giving us what? Giving us hydronium plus HSO4 minus plus another hydronium plus what? Plus sulfate ion. Okay, so if you can check, right, what is on the left and what is on the right. If we have something on the left and that is also on the right, we can check the quantity of what we have. So if the quantity is the same from the left and from the right, so those two things, it means they are just spectators. Okay, so we can cancel them out. So on the left, how much water do we have? We have water plus water. Okay, on the right we don't have any water, so water is not a spectator. So also on the left we have sulfuric acid, H2SO4. On the right we don't have that. Okay, now here we have hydrogen sulfate. We also have hydrogen sulfate on the right. So it means now the hydrogen sulfate is what we call a spectator ion. Okay, so this is going to cancel with what? With that. Okay, so now what are we going to have? So now on the left we're going to have H2SO4. So we have how many waters? One, two water molecules. Two water molecules, right? And then now, how many hydroniums do we have? We have one, two hydroniums on the left, on the right, sorry, two hydroniums on the right, and then we have what? Plus SO4, 2 minus. Okay, so they can ask you, you know, about this two-step reaction of sulfuric acid. Okay, so I just want you to be wary of that and know the content of chemistry. Don't just cram question papers and memorandums. Here on the portal, we kill chemistry. We focus in the real content of chemistry. Okay, so now that's all there is to it with the diprotic and monoprotic acids. So now let's talk about neutralization, reactions, and hydrolysis. Okay, so let me start a new page. Okay, so neutralization, reactions, and what? And hydrolysis. Okay. All right. So now, uh, what is this neutralization reactions? So it's when we add an acid to a base. So remember that a base, uh, it is alkaline, and then acid, it's acidic. Okay, so when we add acid to a base, and the amount is their amount, they are equivalent at some point we call equivalence point, we will achieve neutralization. Okay, so neutralization reactions, we have what? uh, so what are we going to have? We have what? Acid plus base. What do we get? We get salt plus water. Okay, we get salt plus water. Okay, so now, uh, and sometimes we can get what? We can get carbon dioxide plus water. Salt, carbon dioxide plus water. So depending on what base are we going to use. So if we use carbonate bases, excuse me, we are going to get carbon dioxide as a result. Okay, so we can also have acid plus base and get what? Salt plus what? Carbon dioxide plus water. So but this base, it must be a carbonate base. Okay, so uh, I'll I'll give you few examples of neutralizations that you guys must know that are commonly used in the laboratory. Okay, so now, uh, if I say I have HCl in aqueous solution plus what? Plus sodium hydroxide. Okay, so here what is going to happen? You can check what is going to happen here. We know that uh, this H, it will be what? A proton, right? This is a proton and this is a negative, and here the sodium is a Na plus, and then here we have what? OH minus. Okay, so positive attracts negative, right? So now this hydrogen will go to what? To OH minus, and this Cl minus will go to Na plus. Okay, so what are we going to have? We combine Na plus and Cl to form what? Sodium chloride. Okay, so plus now that H plus and what? And hydronium, sorry, and hydroxide, when they combine, they form what? They form H2O. Okay, because two hydrogens and one oxygen atom. So now what do we have? We have acid. Here we have a base. Here what do we have? We have a salt. Here what do we have? We have water. Okay, so because we have classified acids and bases as strong and weak, now you can tell that we are doing neutralization of strong acid and what? And a weak strong acid and a strong base. Okay, So now if I can say uh, now I take a strong acid and a weak base. Okay, uh, strong acid and a weak base. Choose a weak base. For example, let's choose uh, sodium carbonate and let's see what is going to happen. Okay, so now again here H plus and what Cl minus. Okay, here we have 2 Na plus. Okay, and then I have what? I have a carbonate with a 2 minus. Okay, so uh, positive attracts negative. Okay, so now here this carbonate, it must be attracted to what? Uh, to two protons, because now it is a negative charge of 2. Okay, so and also this Na plus, we have 2 Na plus, so it must be attracted to 2 Cl minus. So here, mean already we can see that we need to have 2 here. Okay, so meaning that we have 2 of this and 2 of that. Okay, so now 2 of hydrogen ions will go to what? To the carbonate. So these ones will come here, and then 2 of the chlorine ions will come here. So we'll have NaCl times 2. Okay, 2 sodium chloride plus what? Plus uh, carbonic plus carbonic acid. Okay, so now when they write these equations, they don't write carbonic acid as it is like that, because remember I said that if we have a neutralization reaction of acid and a base that is a carbonic, sorry, that is a carbonate base, will have carbon dioxide plus water. So this carbonic acid will decompose to form carbon dioxide and what? And water. Okay, so you will see that this reaction, you have what? The product of this reaction is 2 sodium chloride plus what? Plus carbon dioxide plus water. Okay, so and then you are fine now. So what about the stoichiometry of the reaction? So check the stoichiometry. Okay, have you checked? Okay, so now for every 2 moles of HCl, 1 mole, right? For every 2 moles of HCl, that donate a proton. 1 mole, 1 mole of sodium carbonate will accept a proton. So now this is a stoichiometric ratio. Okay, so now from this the notation can also be like this: 2n for number of moles, 2 mole of HCl, right, to what? To 1 mole of what? Of sodium carbonate. You see, so many learners, they are being confused by this notation. So it's just the same thing as this one. Okay, so they are the same, they mean the same thing. Okay, so also the notation can be written like this: 2 mole of HCl is to what? To 1 mole of what? Of Na2CO3. Okay, so it's the same thing. Remember, ratio means we are dividing. Okay, so now we have to know the reactions of neutralization. Let's take this one of a weak acid and what, and a strong base. So COOH. So if I say COOH, what is this? This is oxalic acid. I add it to sodium hydroxide. Okay, so what are we going to get here? We're going to get sodium oxalate. Okay, sodium oxalate, so which is something like this: COO 2 and what, and Na2. Okay, so plus what, plus water. Okay, so now you will notice that this equation is not balanced. So because here we have two hydrogens that are going to be donated, so there must be two hydroxides that are going to accept the two protons that are being donated. So here we need to put 2. Okay, and then now because 2 protons are being donated and 2 hydroxides are being given to accept the protons, so even on water we must have 2 water. Okay, so now one thing that most learners they are not aware of is the structure of the oxalic acid. So the structure of the oxalic acid is like this. It's like a dimethanoic acid. If you are looking at it, it's something like this. Okay, so this proton is donated, and also this proton is donated. Although it donates 2 protons, it is still a weak acid. Okay, so which makes this acid what? A diprotic acid. Okay, a diprotic acid. So a reaction between a diprotic acid and a strong base. So a strong base, I'm talking about sodium hydroxide and potassium hydroxide. So for each and every diprotic acid, we'll always need 2 moles of sodium hydroxide or potassium hydroxide. Okay, so the stoichiometry in this part is what? Is 1 mole of what? Of oxalic. Okay, 1 mole of oxalic acid that reacts with what? 2 mole of sodium hydroxide. That's also react. Okay, so the ratio is what? Is 1:2. You see? Okay, so now in terms of stoichiometry, I think you guys will be able to manage, because everything, the minute we bring a reaction, there is stoichiometry that is involved, so you must be able to use a stoichiometry. Okay, so now uh, notice that there's another thing that I want us to talk about. Okay, so you will study all the reactions of neutralization, reactions of common laboratory acids and bases. So I did not write all of them. So inside the page of the portal here on YouTube, there is a link to the group called the portal. Inside the portal, I have uploaded the examination guidelines, whereby you can see the reactions that I'm talking about in full and study them. So now let me talk about hydrolysis. Okay, hydrolysis. So now, what is this hydrolysis? Hydrolysis is actually the reverse of uh, neutralization. Okay, so if this is neutralization, right, and then this is hydrolysis. Okay, so they are reverse of each other. So meaning that now hydrolysis is what is when we add remember that neutralization, we are mixing acid plus what plus base agar. What do we get? We get salt plus water. Okay, so now if these reactions are reverse of each other, neutralization is reverse of hydrolysis, what is going to happen here? We can see that hydrolysis is salt plus water, giving us what? Giving us acid plus base. Can you see? So now, what is the definition of hydrolysis? Definition of hydrolysis is what? The reaction of a salt with water. Simple like that, guys. You get 2 marks for knowing this. So the reaction of a salt with water, so salt plus water, that's hydrolysis. So which is what I have shown you here. Okay, so there are few guidelines that are there on hydrolysis that I'm going to show you. Okay, so but before I can show you those guidelines, I have to talk also about the neutralization, that when we mix strong acid and a strong base, what happens? Strong acid with base, what happens? Okay, okay, so I'm going to give just an example, like, or 2 examples, and then I will explain further what is a hydrolysis and what are the, you know, other things that are discussed in hydrolysis. Okay, so but it will be on the next video, which will be focusing on hydrolysis and neutralization and what and conjugate acids and bases. Okay, conjugate acid base pairs. So this one it will close. So now if I say examples, okay, examples. So in my examples, let's say I have sodium chloride plus water. Okay, if I have sodium chloride plus water, okay, let me not use this one. Let's say, yeah, let's say sodium oxalate plus water. Let's take sodium oxalate. Sodium oxalate plus water. What do we get? We get oxalic acid plus what? We get oxalic acid plus sodium hydroxide. Okay, so remember now we are getting a diprotic acid. So for each and every diprotic acid that reacts with a strong acid such as sodium hydroxide or potassium hydroxide, we will need 2 moles of sodium hydroxide. And then here 2 moles of water will be formed. Okay, plus 2 moles of water. So this is hydrolysis of what? Of a weak acid, right? So we can see that it is forming a weak base and what? A weak acid and a strong base. Okay, so another example will be, let's say now let's take okay, yeah, let's take sodium ethanoate in water. Sodium ethanoate. Sodium ethanoate plus water. Okay, plus water to give us what? Remember, the hydrolysis equation has a reversible reaction. Okay, so it has a reversible reaction. So what are we going to get? We're going to get ethanoic acid plus what? Plus sodium hydroxide. Okay, plus sodium hydroxide. Notice we have a weak acid, we have a salt resulting from a weak acid and a strong base. So if we take this salt and do hydrolysis of the salt, we get what? A weak acid and a strong base. Okay, so that's all there is to it for this lesson, for lesson number 2. So we will do lesson number 3. Okay, so thank you guys. Don't forget to like, share and subscribe.